Hello everyone, my name is Konstantinos Arabatzis. I'm from Berghof and I work here for already 13 years, mainly as a technical support engineer, but I have also been an application engineer when I first started my career here. Joining us today will be Gniadzik from our partner company ASTOR in Poland, and he is an industrial control system specialist.
Hello.
Okay, a small overview of the topics. What we will do, I will do a brief company and products introduction. I'm just browse through some slides. I won't go into any more detail inside here. And then we will have the two topics. I will present the no-code programming robotics technology module from Linmod, and Adam will present the 3D printing application for construction sites. So, who is Berghof? We are your system provider for demanding control tasks in plant engineering and worldwide equipment. Berghof specializes in customized solutions based on a highly flexible standard portfolio, combining maximal fulfillment of requirements with maximum qualitative product safety. The hardware and software components impress with their sophisticated function and maximum reliability, even under extreme loads. A quick overview of our portfolio. We have three product families. First is the B Previous series, which are display devices. Here we have released this year a new product, or several new products, which is the DC Pi Prime series. It is our Raspberry Pi based display devices. We have three products: the DC Pi Prime, which is a display PLC with the Compute Module 4 from the Raspberry Pi, a custom RTS Linux running CODESYS, and capacitive screen from sizes from 7 to 15 inch. The DC Pi Prime Open is the same device but with a different software. It does not come with our Linux but with the default Raspberry Pi OS, which opens the device to any use and can be used as a small or bigger industrial PC. And last but not least is our ET-Pi Prime, which is our Ethernet terminal. It is a remote display that can showcase visualizations using a VNC client or a web browser. This product has been updated also to the Raspberry Pi and giving it new features. The B40 series is compact devices that we have. They're different in size and with integrated I/O. We have the CC Slim, either with different interfaces. There are different versions, all common interfaces that are used. Ethernet, serial connections are there depending on the version, and we also have the option for a dual core CPU. The CC Prime is even bigger. It has a large number of integrated in and outputs, digital and analog, as well as different interfaces. And the CC-IO are matching I/O devices that run over EtherCAT that can be used with these devices. Last but not least here is the Benime series. These are our modular devices. Here we have our MC Pi devices, which were our first Raspberry Pi based controllers. They have a modular design that can be extended with I/O directly. This extended port is nothing proprietary, it's EtherCAT. And here we also have the version with RTS Linux running CODESYS, and with the open version that is running Raspberry Pi OS. We have different number of I/O modules, and we also have our own safety PLC that is using the CODESYS safety extension. All our PLCs come with a custom-made real-time Linux made by Berghof. We are experts here and are doing this for over 20 years. All our PLCs support the native CODESYS v3. We don't have anything proprietary, and all PLCs can be customized with our option systems and just include features that customers really need. Communication protocols, you can see here EtherCAT, Profinet, like the usual suspects that are used, and different software options like WebVisu, USB accessories, FTP server, motion, soft motion, backup restore, application protection, and IoT libraries, as well as integrated VPN functionality. General fields where we are active is classical industry and machine building, can be handling systems, pick and place systems, packaging systems, like different kind of applications. We have like special technology for conveyor technology, and we are also quite present in the building automation. Let's come to the first part now, the Linmod pilot. First of all, who is Linmod? Linmod is part of the NTI AG, Linmod and MaxSpring from Switzerland. And Linmod develops, manufactures, and distributes high-quality linear motors, linear rotary motors, linear modules, and linear systems for use in industrial automation. You get everything for linear motion from a single source. The headquarters of NTI AG is located in Spreitenbach near Zurich in Switzerland. As an international and innovative company with an experienced customer service, sales, and support network, they are always competent to reliable car partner to the realization of linear and rotary movements. Okay, so what is this technology module? What is this Linmod pilot? This is still an ongoing project. It's it has been officially shown at exhibitions. Yes, and what is this? It is a technology module. Because you can highly customize it. The Linmod Pilot technology module is an intuitive no-code solution which enables effortless configuration and control of multi-axis kinematics, also single-axis kinematics, depends on your use case, through a user-friendly web interface. Predefined function packages can be activated at the push of a button. Positions taught via a teach button or manual movement. The platform is scalable with additional packages and applications, along with customizable widgets for tailoring the HMI and control area to individual needs. So basically, they took our controller and they developed a huge application on it that allows the end user to use different kinds and to program different kinematics depending on what the use is, with some predefined functionality all over a no-code platform that is done with Visu. So no struggles with development tools for the end user, no high-level programming skills required, intuitive usage and testing of own programs, minimal training time, accessible to non-experts, rapid prototyping for quick results, and know-how-driven applications like screwing or thread checking, simplified with configuration wizards. This technology module is interesting for everyone who wants to automate by themselves, but does not have the specialist, who wants a flexible system where quick modifications can be done, who wants to extend his system with a new process, and who wants to have quick results in a short time. I will show some videos like for a quick demonstration on how it can look like. Here we have a demo machine that is actually running two different kinematics at the same time, which are synchronized to each other. A simple demo. Again, this is two PLCs, two different kinematics, two programs, and they're synchronized by each other and are doing like this pick and place and assembly motion. Another short video, just like to showcase on how this looks like. You create your programs in an interface, a table interface like this, where you have all of your steps. It reminds a little bit to G-code, but it's not actually G-code. And you select your steps, and here you have a huge toolbox of different packages, single-axis motions, multi-axis motions, and you go step by step. And then you just select like what kind of motion do I want to do, and what kinematic do I want to use. Like it's just set up, it's clicking and creating your application. and then you can let this run. And that's how it looks like then live. You can see the program and all of the steps that are going through. And you could see like what the movement actually was. And here they have a small assembling screw movement, just as a simple demonstration. So we have seen the module. Now, how they found CODESYS and why did they decide to use CODESYS in Berghof? The project began, I think, about 3 years ago. When they wanted to create an easy-to-use kinematics module. They were not hell-bent on CODESYS from the start. They tested several PLCs, several platforms, and several IDEs. But in the end, they decided to go with CODESYS for 2 reasons. One was that they had seen that the EtherCAD master in CODESYS was very well implemented. It ran very stable. And that they had access to open platforms like the Raspberry Pi, which like the first prototype was actually based on, and how they started. How did they come to Berghof? At some point they saw, okay, we have the Raspberry Pi, we could use it, but we need a more industrial solution. And like preparing the software and everything by ourselves. Okay, we can use the OS, we can do a real-time patch, but basically they want the PLC in this case to be a black box. How do we create the black box with the Raspberry Pi? And so they started looking around on other devices based on the Raspberry Pi, and they found our MC Pi controllers. It is already a finished product, like the RTS and Linux was already implemented as they envisioned it. And we also had our own firmware. We had features for accessing without additional software and doing updates and doing updates to the application without the need of CODESYS. So we could fit this black box mentality that they had quite well, and that's when they decided to go with us. What devices are used in this application? Like the main device is the MC Pi Prime. It is the middle-sized MC Pi controller when it comes to interfaces. And they use it for access control and for the web visualization. The main field bus here is, of course, EtherCAD. They run with a bus cycle time of 2 milliseconds and can configure up to 8 axes. And depending on the machine, sometimes they also have optional I/O slaves. They use their own Linmod drives, the C1250MI linear drives, and when I/O are needed, they're using our own MC I/O slaves. Secondary field buses that were quite important are Profinet and Ethernet to be able to connect to higher level PLCs. And also they're preparing to integrate OPC UA like Industry 4.0 and like a more open approach to share data with other systems. What were the main challenges that they faced when developing the application? CODESYS, a lot of people know it. It's quite easy to learn, but quite hard to master. And mastering the EtherCAD master in this case was quite challenging. The setup and getting it to work is very easy, and many people love it. But what was very important for them was the dynamic slave configuration. And there they struggled a bit, but got it working. And then the end was optimizing the system and the application for good real-time performance. Here they were also closely working with us. They also helped figure out some bugs in our firmware to improve the performance and to stabilize the low cycle times, as well as creating and optimizing the visualization that they use, because like it's quite a big visualization and with a lot of features for functionality and performance. What were the key features and CODESYS that they used? already mentioned, the EtherCAD master. It is well implemented and easy to use. And with our system, they were also able to get low jitter and high cycle times. And again, to be able to use the dynamic configuration of slaves, which allow varying number of motors drive to be connected even after the application has been compiled. The dynamic configuration, just as a side note, is not okay. I have in my EtherCAD configuration, I have all the devices and some are optional. It is when the EtherCAD master is empty, and then at startup, I scan the bus and then dynamically add the devices that I have found in the bus and dynamically create the EtherCAD slaves. This is the dynamic configuration. There is a very quite extensive CODESYS example that you can find in the CODESYS online help. They also use that to get started. But getting it to work until, yes, it worked as they wanted took some time. CODESYS field bus, the wide range of field buses that are allowed, that they can use. Primary focus is Profinet and Ethernet IP and OPC UA for exchanging data. What was important is they could also use the Profinet or the Ethernet IP in low cycle times to exchange data with higher level PLCs, and the secondary bus should not interfere with the main bus, because that can be quite a big problem on different systems. It was not a problem with our systems. Okay, one moment. Sorry. Can you hear me better now? Test, test, test. Okay, perfect. Sorry about that. Should I go back? Okay, no. Perfect. The field buses should run independently from each other, not influencing each other. And like we have this integrated in our system by using the different cores that are available on the on the Raspberry Pi. But it's not only like selecting a different core, pinning a different task group inside CODESYS. We also have integrated this into our system that we use isolated CPU cores for different masters. So the EtherCAD is running at core 3 as is isolated, and the Profinet or the Ethernet IP are running in core 2, which is also isolated, and thus we have a stable running field buses for their use. Of course, what is very important here is the CODESYS soft motion that they're using extensively. They have a multi-interface drives that are controlled by CODESYS project via EtherCAD DS402, of course, made possible by the extensive soft motion library. Here they use various kinematic transformations that they create also dynamically depending on the type of kinematics that you configure inside your applications. It's very well made, and they said like they praised like the CODESYS soft motion and the kinematics that are there a lot. Future updates might also bring CNC functionality. And last but not least, of course, the visualization was one of the most important aspects of the project. The user interface should be more comfortable, intuitive, and clear for the end users. And they put like a lot of design in it. Initially, this was achieved using various individual visualization elements that were manually assembled and using grouping and stuff. But soon they realized that they can approach this with many similar elements and duplicated code by using the frame. And with using the frame and FB-based controls that basically brought an object-oriented programming design into the visualization. And this gave the code and the control of the visu and the possibilities of the visu much better structure. The organization and the modular design made it more maintainable, and they also optimized were able to optimize the performance of the visualization a lot like this. Also, what they really like is the using the streaming functionality, the file streaming functionality through the visualization, because you can also exchange everything goes over WebVisu. You can also load from your PC data into the visualization directly on the PLC, and they utilize this a lot, which they also liked. Okay, in the end, what other CODESYS features did they use? CODESYS Git was very important for them, and they were surprised that it was there, because for many years CODESYS supported only SVN, but Git is now also part of it, and they used it quite extensively. And otherwise, which Berghof features did they like? First of all, is the easy-to-use web interface of the controller for main configuration. You don't need any extra software to be able to configure our controllers. And they also like the backup and restore functionality that our PLCs have, which is also like part of this black box approach. If they want to send the customer an updated application, they create the backup locally and can just send archive to the customer, which you can, again, using the web interface, update it, or using USB, update it, and get the newest version without the need of any higher knowledge and CODESYS usage. Okay, so far so good. I am at the end of my presentation. Thank you very much for your attention, and I give the mic to Adam.
Thank you very much. I hope I'm heard. My mic is okay. I'll take sharing of my screen. Okay, can you see all the presentation right now?
Yes, yep. Looks perfect.
Great. So basically, I'm really happy to, as I was invited by Konstantinos, I'm really happy that we have a chance to work together. Although what makes me the happiest right now is a chance to share for you the Polish thought of engineering. And before I start with the main topic of this presentation, I'd like to say a few words about an organization I'm working in right now, a company called ASTOR. And basically, when we look at the certain data, you can see that, or you can imagine that we have over 35 years of experience, as ASTOR as a company was founded in 1987. We integrated and helped to integrate over 50,000 systems for digitalization, automation, and robotization. Through our consulting and schooling, sharing materials, we trained over 21,000 engineers. And when we think about employees, we right now have over 200 people on the board. So there's one certain value I want to show you. Maybe it's when you look at it, it doesn't mean much, but when we press space, it's amount of years that is summed up with all of the employees of ASTOR. So basically, average of people working here is around 12, 13 years, as I'm correct. Okay, we got nationwide coverage. As I said, we are located our central in Krakow, but we don't only focus on Poland. As we are cooperating with other companies such as Kawasaki Robotics, we are also as Central Europe and Eastern Europe hub for robotization of Kawasaki robots. we have four main business lines and four main areas that we are focusing on as we are divided in teams. Industrial automation control systems, where we focus mainly on process and machine control systems, also of the certain processes of automation, and also industrial communication. We got a business line focused on digital transformation on manufacturing, where we are talking mostly about systems connected with data acquisition and visualization, but also management execution systems, or OEE. Then we are, the next business line is intralogistics, where we focus on in-house transport and self-propelled robots, and robotization, where we talk about pick-and-place applications, welding, or palletization, whatever our customer needs, yeah? Who trusted us, because that's really important, I think, and we can be proud of this. We work with small and medium businesses, but also large enterprises and global manufacturing enterprises such as IKEA, Nestle, Volkswagen. So the over 35 years experience can be shown through this cooperations. Yeah, if you ever have a chance, and I hope you do, because Poland is really beautiful country, and you'll have a chance to be in Krakow, feel invited to visit Smolensk 29, as we got their innovation room in which you can see and touch even the technologies connected primarily with Industry 4.0. And also on the offside of Krakow, we got our robotics center, where you can look and test our robotics applications. ASTOR is not a single company. We got competence centers that are focused mostly on MES, IoT, motion, and, as I said, aerial CE hub for Kawasaki Robotics. Okay, but let's talk about main topic, scalable industrial systems. And the main question is how to prepare a 3D model on your desk and then print it on the construction site. So, as I said earlier, I'm Adam Gniadzik, industrial automation control system specialist. Right now, mostly focused on the cybersecurity aspects. But I had really great opportunities to work with companies that are creating R&D projects, and I want to talk about more and tell you about it. Okay, so basically, how are innovations tailor-made? Okay, you may have heard or not the concept of personalized medicine. Okay, so it's a unique way of satisfying needs of patients. Known examples you could notice every day are prosthetics and orthopedics. Basically, if we want to create convenient equipment for patients, we need to first measure certain parameters. Dimensions of limb, weight, interview the patients if their needs are in somewhat special. And in this case, this approach has gotten recently really much more popular. When we think about it, even 3D printing is being applied to solve those needs. So we can use 3D printers for elements of prostheses, including dental ones, creating surgical equipment, and so on. And basically, few characteristics of personalized medicine are personalized approach to needs, early issue detection, holistic and interdisciplinary approach, and information-based decisions. So when you think about it, that's something in common when you think about all the automations and working with clients, integrating systems to suit their needs. So everyone can buy today a 3D printer, any one of us. Basically, it's a really, really easy machine to operate. We model object on our computer, we parameterize the process, and then we print physical object. Mostly iterate, because the first model on the printer is like a first pancake, straight to bin. And this isn't nothing new. It's like a technology that was in the 70s, 80s was created. So it's nothing new. But it's kind of really big idea if we could take this whole concept and transport it to a construction site, yeah? Okay, so as you see here, it is an industrial 3D printer that operates mostly with concrete and creates such buildings. What you see on the left is a building made for trash bins for McDonald's in Poland. I can tell right now which city, but it was somewhere in Mazovia. It's much more bigger. It's around 5 meters and 5 to 8 meters if we talk about the base plate. So as this whole concept has grew, we need the bigger equipment, more serious one, yeah? So we got 3 layers of this solution, yeah? We got, as in the home 3D printer, we got a layer of object modeling, in which we use industrial PC. Then we go to the parameterization of the process, where we include the solution from Berghof automation. And then we got print of physical objects, where we mostly work on the servo motors and inverters. So basically, each layer of this control system has different characteristics. The object modeling and process of visualization, as I said, is realized on the PC. And they all functionality behind with calculating the movements and translating the G code that's created on the PC is made on the PLC that has integrated CODESYS. And then when we talk about certain movements in a physical way, we need those servo motors and inverter for the printing nozzle. So in the first layer, also we can, besides creating geometry, generating SLD files, cutting up each layer, we can preview the process thanks to the web server. We created the whole idea to work to the computer that works like a operation, like a operator station. We also collect the historical process. All the data acquisition happens and it's saved there, so we can learn from our mistakes. Then we have all the processing G-code into comments, thanks to all the possibilities granted by the CODESYS and Berghof PLCs. We execute the logic. We create their web server for the operator station. All communication is really fast because it needs to be really fast. And it's working mostly through EtherCAT, but some data is sent to the PC through TCP/IP. So whole PLC is working like a protocol concentrator, yeah? What's more, we can make this, as we know, this would work on the construction site. We have some safety functions also delivered by Berghof, and we can make this whole process of safety logic air-gapped in some way from the original logic, so it would independently work on the safety controller. And the most important is the execution layer, of course, where we can see the building or the element printing. On each of the inverters and servo motors, we can monitor overloads, failures, and whole monitoring of the specified parameters. The image you are seeing right now is the technician stairs for the railroads that was created with this 3D printing equipment. So, effects of cooperation. Right now, our partner, the company Rebuild that we were working with, created the first in Poland parkour park. Parkour is a French art of movement through the city, of moving through the city, I think. And as it needed certain objects in the park, and all the equipment needed the certain non-usual geometry, they used the 3D printer, and it looked really great. The people living in Warsaw that are seeing this park aren't seeing the value, but for me as an engineer, I'm really impressed. Yeah, so the summary of whole project. We created a convenient solution for prototyping concrete semi-finished products, which don't require any form or mold, because the concrete got distributed reinforcement. So it's easy. It's really easy to apply on the construction site. We use G-code that's known and is really enjoyable to read for the operators of the CNC machines. The model creation and parameters setting is user-friendly, as the whole interface looks like the interface for home 3D printers. We ensured the machine is safe, and with an independent safety controller with SEAL3. It's really convenient to diagnostic, thanks to the web server and visualization that was created based on the CODESYS. And we can reduce human impact on the printing process thanks to that, as it really increased whole repeatability. What's more, the solution is scalable. Really, workplace and baseplate is no limit. Expansion is expanding the machine is possible within the single environment, and we can print concrete, print with foam plastics as we tested, and even perform 5-axis milling. So I think it's pretty impressive. That's all for me. From me, if you got any questions, you can ask. I'll be really honored to answer them. And below there are my contact details if you seek some further informations.